Hello students, welcome you all back to my channel Khan's Commerce Tutorial. Presently we are discussing the subject Business Statistics 2. In this subject so far we have completed two topics, two units, that is probability and theoretical distribution. So in probability, in one video I have completely explained the introduction to probability, different concepts. Then a number of videos I have prepared for problems on probability. More than 50 problems we have solved. So if you want the complete command on this topic of probability, go back to a playlist, select the videos of probability, watch it carefully, definitely you will get a good command. Apart from that, we have completed theoretical distribution. Under theoretical distribution, we have completed the binomial distribution, Poisson distribution, normal distribution, so many problems we have solved. So if you want the complete command on these topics, go back to my playlist, select the concerned videos, watch it again and again. Definitely you will enjoy a lot in gaining the knowledge. Now presently we are going to start the new topic of Business Statistics 2, that is permutation and combination. But before starting the subject, I expect that my viewers, that my students are having a hard copy of all the problems which we are going to discuss here. So go to the description. In the description, in the last line, you will find the link there. Click the link and get a copy, hard copy of the problems, and keep it ready before watching the video. Then only there is a purpose, there's a meaning in watching the video. Otherwise, simply if you watch the video, you are not going to get any gain. So please follow my instruction for your benefit only. Come on, now we'll start permutation and combination. Permutation and combination, actually it's a topic of mathematics, but it is included in statistics because the permutations and combinations concepts will be used in other topics of statistics like probability, like theoretical distribution. So in different topics of statistics, this concept will be used of permutation and combination. So we are not going in depth in this topic because we want only basic fundamental knowledge of permutation and combination. Come on, let's begin the theory. The permutation and combination. First we'll discuss about what is this permutation and combination. Permutation and combination is the study of arrangement and selection of objects. Arrangement and selection of objects of different variables. So example, simple example. With the help of example, I can easily explain you the meaning of the term permutation and combination. Suppose a jury is there. He has to select the best actor male, the best actor female among 10 nominations. Out of the 10 nominations, 5 males or 5 females are there. Now he has to select 2 persons out of 10 persons in such a manner that one person should be male, the other person should be female. It's a problem of selection. Technically, it will be called a problem of combination. Another example I'll give you. Suppose in a cricket team of 11 players, the captain of the team has to select 2 openers. Now there's a question, how to select 2 persons out of a total team of 11 players? So it's a problem of, again, selection. It's a problem of combination. Another example, after selecting the 2 openers, let the openers be A player and B player. Now the captain has to decide who should go on the striker's end and who should be on the non-striker's end. If A is going on striker's end, B should stand on non-striker's end. If B goes for striker's end, A should be on non-striker's end. It's a problem of arrangement. So before studying the problems, before solving the problems on permutation and combination, you should be clear regarding whether it is a problem of arrangement or selection. If it's a problem of only arrangement, permutation will be applied. If it's a problem of selection, combination will be applied. That knowledge you must have. This is a brief introduction about permutation and combination. Now, fundamental principle. The fundamental principle is the study about the selection of different items, selection of 2 or more items, or study of arrangement of different items. Simple example I'll give you. Suppose the captain of the cricket team has to make a combination of 1 batsman, 1 bowler. Totally 4 batsmen are there, T1, T2, T3, T4, and 3 bowlers are there, O1, O2, O3. Now the captain has to make a combination of one batsman and one bowler. So how many ways he can make a combination of one batsman, one bowler among 4 batsmen and 3 bowlers? So totally we can have 12. How 12? I'll show you with the help of an example. Suppose 4 batsmen are T1, T2, T3 and T4. These are the 4 batsmen and 3 bowlers are there. So I will take O1, 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 O1. Similarly T1, T2, T3, T4. Here O2, 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 O2. Then T1, T2, T3, T4. Here it is O3, 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 O3. So how many ways he can be able to choose two players, a combination of one batsman and one bowler. So 4 batsmen, 3 bowlers. The combination may be T1 over first batsman and first bowler. T2 over second batsman, first bowler. Third batsman, first bowler. Fourth batsman, first bowler. Or first batsman, second bowler. Then second batsman, second bowler. Third batsman, second bowler. Fourth batsman, second bowler. उसी तरह same way, first batsman, third bowler. Second batsman, third bowler. Third batsman, third bowler. Fourth batsman, third bowler. So totally 12 ways are there. 1, 2, 3, 4. 1, 2, 3, 4. 3 is a 12. So this fundamental principle says if we have 2 tasks, let first task be T1. And this T1 task can be performed in M ways. Another task T2. That T2 task can be performed in N ways. So totally how many ways we can be able to complete the 2 tasks T1 and T2? So simply we have to multiply M into N. M into N. So here we have M is equal to number of batsmen 4, N is equal to number of bowlers 3, 4 into 3, 12. So this is the fundamental principle in permutation and combination. Now factorial. The factorial is simply a number. A factorial of a number is simply the product of all the numbers. The product of all the numbers to 1. Product of all the numbers up to 1. For example, 5 factorial. The symbol of factorial will be like this. This is the symbol of factorial. Suppose if we want 4 factorial, the 4 factorial means the product of all the values from 4 to 1. From 4 to 1. So it will be written as 4 into 3 into 2 into 1. Similarly, 5 factorial means 5 into 4 into 3 into 2 into 1. 8 factorial means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is called factorial, which will be frequently used in permutation and combination. Next, the next topic is meaning of the term permutation. Meaning of the term permutation. The permutation is an arrangement. Permutation is an arrangement in a definite order. In a definite order of a number of objects. Taken all the items or some of the items at a time. So permutation is nothing but the arrangement in a definite order of a number of objects, taken all or some of the items at a time. Simple example I'll give you. Suppose we have to select 2 alphabets. We have to select 2 alphabets and arrange it out of 4 alphabets. The 4 alphabets given are L-O-V-E, love. So how many ways we can select 2 alphabets from these four alphabets? How many ways we can arrange two alphabets out of the total of 4 alphabets? So we can list down the permutations, list down the possibilities of taking 2 alphabets at a time out of 4. So we can take L-O-V-E. So first 2 will take L-O, then O-L. L-O is the 2 alphabets, then O-L is the 2 alphabets. Then we take L-V, then V-L, then we take L-E, then we take E-L, then we take O-V, then we take V-O, then we take O-E and E-O, then we take VE and EV. is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I want to explain is, out of the 12 alphabets, we are making a combination of two alphabets at a time. So how many ways we can arrange two alphabets out of a total of 4? So I have listed down the possibilities of taking two alphabets at a time. So I found that ways. There are 12 ways I can be able to arrange two alphabets at a time out of 4. This is nothing but permutation. Similarly, another example, suppose if a coin is tossed 2 times. What are the possibilities? What are the possibilities of outcome of coin is tossed 2 times? The possibilities are, first time we may get head. Means first time head, second time head. This is a possibility, one possibility. Second possibility is head, tail. First coin showing head, second coin showing tail. Third possibility, tail, head. Tail, head. First time showing head, tail. Second time showing head. Third possibility, tail. First time tail, second time tail. So when 2 times the coin is thrown, the possible outcomes are this one: head, tail, head, tail. So this is a problem of permutation. Now regarding permutation, how to find out how many permutations we can get when we select R items at a time out of a total of N items. Here N items are 4 items. R means 2 items. We are selecting 2 alphabets at a time out of a total of 4 items. So how many ways we can be able to arrange? 12 ways. So if the numbers are small, if the N and R values are small, we can easily list down all the permutations. Agar for example N, यहाँ पर N 4 है और R 2 है, so only 4 alphabets are given. Out of 4 alphabets, we are selecting only 2 alphabets. So 2 and 4 are very small figures. So easily we can be able to list down the possibilities of this. But imagine when we have to select 11 numbers out of a total of 40 numbers. Total number of alphabets are 40. 40 values are given. Out of 40 values, we have to select 11 values at a time. So imagine when N is equal to 40, R is equal to 11, it will be very, very daunting task to find out all the permutation. In that case, we need a formula to find out how many permutations are there. So for that purpose, the formula is NPR. The formula is this one. NPR is equal to N factorial divided by N minus R factorial. This will give you how many ways we can be able to select R items at a time out of a total of N items. The total number of items are N. Out of N, we are selecting R items at a time. R items at a time. So how many ways we can be able to select it? That will give you NPR. This formula we are going to apply. For example, if there are 5 values, if total number of alphabets are 5 and we are selecting 2 items at a time, so N is equal to 5, R is equal to 2. So 5C2. What we get is 5P2, sorry. Not C2, 5P2. So how many ways we can be able to arrange alphabets out of a total of 5. So when total number of alphabets are 5 and our number of alphabets we are choosing 2. So how many ways we can be able to select 2 items out of 5? So we can write NPR is equal to 5P2. That is equal to 5 factorial divided by 5 minus 2 factorial. 5 minus 2 factorial. So how to solve this one? 5 factorial divided by 5 minus 2 is 3. So 3 factorial denominator. That is equal to 5 factorial, 5 into 4 into 3 factorial divided by 3 factorial. So numerator 5 into 4 into 3 factorial. I am not going beyond 3 because denominator we are having 3 factorial. So we can be able to cancel 3 factorial, 3 factorial. Now 5 4s are 20. So our answer is, in 20 ways we can present two items at a time out of a total of 5 items. अगर 5 अल्फाबेट है तो उसमें से दो अल्फाबेट एट ए टाइम हम चूज करके पेयर्स बनाएंगे. तो कितने पेयर्स बन सकते हैं? 20 पेयर्स we can be able to make. Like that. Any number. For example, if n is equal to 50, then n is equal to, let it be 10. Let it be 10. Right? Yeah, will be take 40. 40. N is equal to 40. Now substitute 50p40 is equal to. So 50 factorial divided by 50 minus 40 factorial. Like that we can be able to find out how many ways we can be able to arrange. This is about permutation. Now permutations are of two types: linear permutation and circular permutation. Linear permutation means when we are arranging the objects in a straight line. For example, if 5 seats are available and 5 VIPs are to be seated on those 5 seats, so how many ways the 5 seats can be occupied by 5 VIPs? Example, first seat will be allotted to A VIP, then second seat to B, third seat to C, fourth seat D, and last 5th seat E. Like this, one possibility is there. Apart from that, what are the different ways? How many ways we can be able to make them sit in a straight line of 5 seats and 5 VIPs? This is a problem of linear permutation. Linear permutation. In this case, what will happen? A is the first person, he is occupying first seat. So he will not have any neighbor on left side. So that means he will have only one neighbor. A seat, A person, he will have only one neighbor. Similarly, last E person will also have only one neighbor. Whereas the remaining B, C, D, these 3 persons will have two neighbors. Two neighbors. This is the linear permutation. Circular permutation means when all the items are arranged in a circle. Example, the 5 VIPs are sitting in a round table in a restaurant. In a restaurant, a round table is there. On the round table, 5 seats are arranged. Now there is no first seat and the last seat. Any person can occupy the first seat. जो भी पहले बैठ जाएगा वो first seat हो गया. अब remaining seats are available for 4 persons. This is called circular permutation. The number of permutation which we get in circular permutation will be normally lower than linear permutation. In linear permutation, we apply the formula NPR. Then circular permutation will apply the formula NPR divided by R. Divided by R will take. Then permutation with identical elements. This concept will be clear while doing the problem. Permutation with identical. So far we have discussed where every object is a distinct object, different object. But sometimes it may happen that the objects are repeated. The objects are repeated. Example, how many ways we can be able to make two alphabets at a time of the word winning. In this winning, some alphabets are repeated, NN, twice it is appearing. So how many ways we can be able to present the data? When the alphabets, when the objects are repeated, then slightly we have to change the formula. Here slightly we have to change the formula. The formula will be NPR divided by R factorial. That we'll discuss. That we'll discuss while doing the problem. This is a brief theory regarding permutation and combination. Again, I'll tell you, we are not going in depth about permutation and combination because we need only fundamental knowledge about permutation and combination. Because it's a subject, it's a topic of mathematics. In statistics, we need only fundamental knowledge which is applied in other chapters like probability. Right? So this is the end of theoretical part. Now we'll start the problems on permutation and combination. Hope you have taken a printout of the problems from the description. So take out the first problem. I'm reading out the first problem. See carefully. Calculate 3 factorial, 7 factorial, 4 factorial. It's a basic problem first. This problem is given mainly to get acquainted with the expansion of factorial. 3 factorial means 3 into 2 into 1. 3 2s are 6, 6 1s are 6. That's it. Similarly, 7 factorial, 7 into 6 into 5 into 4, 3, 2, 1. Multiply from 7 to 1. You will get 5040. 4 factorial, 4 into 3 into 2 into 1, 24, that's all. This first problem is mainly to get acquainted with the expansion of factorial. Second problem, you see, calculate 6PR. The NPR formula you must remember. The formula for NPR was n factorial by n minus r factorial. That formula will apply for 6p. N is equal to 6, r is equal to 4. So 6p4 is equal to 6 factorial divided by 6 minus 4 factorial. So 6 minus 4, 2 factorial. So 6 factorial by 2 factorial. 6 into 5 into 4 into 3 into 2 into 1 divided by 2 factorial, 2 into 1. Here 2 into 1, here 2 into 1 cancel हो गया. 6 into 5 into 4 into 3, you will get 360. That's all. This is the expansion of 6PR. Similarly, 5p2, exactly similar. N is 5, R is 2. So 5 factorial divided by 5 minus 2 factorial. So 5 factorial divided by 5 minus 2 is 3 factorial. So 5 into 4 into 3 factorial. I am not going beyond 3 because denominator is 3 factorial. Easily I can cancel the 3 factorial in the numerator and 3 factorial in the denominator. So this will be cancelled. 5 4s are 20. 7p1. N is equal to 7. R is equal to 1. So 7 factorial divided by 7 minus 1 factorial. 7 minus 1 is 6. So numerator also will stop at 6 factorial. So 7 into 6 factorial divided by 6 factorial. 6 factorial will get cancelled. 7 will remain. 9p0. So 9 factorial divided by 9 minus 0 factorial. So 9 minus 0 is 9 factorial. So 9 factorial divided by 9 factorial you get 1. Similarly 3p3. 3 factorial divided by 3 minus 3 factorial. So 3 minus 3 is 0. 0 factorial, always remember it will be equal to 1. 0 factorial means 1. So 3 factorial, 3 into 2 into 1, 6. That's it. So two basic problems we have done. First problem, factorial. Second problem, NPR. Now problem number 3. See the third problem. A special screening of a movie has been planned for 3 VIPs. 3 VIPs are there. They have been called for screening of a special movie. And in how many ways can the seating be done? Up 3 VIPs are there. So naturally 3 seats are arranged because it's a special screening of the movie. So 3 seats are there and 3 VIPs are there. So how many ways we can be able to arrange the 3 seats for 3 VIPs? So here N is equal to 3, R is equal to 3. N is equal to 3, R is equal to 3. So 3p3. In 3p3 ways we can be able to arrange. See here, 3 people have to be seated on 3 seats. Number of ways in which this can be done is 3p3. So 3 factorial divided by 3 minus 3 factorial. 3 minus 3 is 0 factorial. 0 factorial means 1. 3 into 2 into 1, 6. So 3 people can be seated on 3 seats in 6 ways. So 6 different ways, methods in which the 3 persons can be arranged. Next, fourth problem. Find the different ways in which the alphabets of the word risk can be arranged. How many ways we can be able to arrange the alphabets risk? R-I-S-K. So how many alphabets are there in risk? 4 alphabets are there. So how many ways these 4 alphabets can be changed? Can be changed. So here N is equal to 4, R is equal to 4. We are taking all the 4 alphabets at a time. And total number of alphabets are also 4. So the required number of permutations are 4p4. Total number of alphabets are 4. There is no repetition. Thus the number of permutations are 4p4. So 4 factorial divided by 4 minus 4, 0 factorial. 0 factorial means 1. 4 into 3 into 2 into 1, 24 ways. So in 24 ways we can be able to arrange the alphabets in the word risk. Next, fifth problem. In how many ways 6 boys and 4 girls can be arranged in a straight line? Total number of persons are 10. 6 boys and 4 girls. So in how many ways we can be able to arrange all the 10 persons in a straight line? So here N is equal to 10. R is equal to 10. We want to change all the 10 persons. Boys और girls मिलाकर 10 है तो 10 को change करना है. तो N is equal to 10, R is equal to 10. So how many ways? 10p 10 ways. So here, since all the boys and girls have to be stand in a straight line, the total number of ways in which this can be done is 10p10. 10 factorial divided by 10 minus 10 factorial. So 10 minus 10 is 0 factorial, 0 factorial is 1. So numerator we have 10 factorial. So 10 factorial means 10 into 9 into 8, 7, 6, 5, 4, 3, 2, 1. Multiply all, you'll get 36,28,800 ways. We can be able to arrange 6 boys and 4 girls in a straight line. That's it. Next, sixth problem. Find the number of 4-digit numbers that can be formed from first 5 natural numbers. The first 5 natural numbers are 1, 2, 3, 4, 5. Out of these first 5 natural numbers, we want to select 4 digits. We want to select 4 digits. First 5 natural numbers without the numbers getting repeated. कोई repeat नहीं हो रहा. So how many ways we can be able to arrange 4 digits out of the first 5 natural numbers? So total natural numbers are 5 here, and out of 5 we are selecting 4. So permutation will be 5p4. So here total number of digits are 1, 2, 3, 4, 5, 5. Number of digits to make a 4-digit number is 4. Thus the total number of permutations are 5p4. 5 factorial divided by 5 minus 4 factorial, 1 factorial. 1 factorial is 1 only. So 5 factorial, 5 into 4 into 3 into 2 into 1, 120. So 120 ways we can be able to arrange 4 digits out of the first 5 natural numbers. Now, seventh problem. 2 photographs. 2 photographs have to be placed on the notice board from a lot of 7 photographs. So totally we have 7 photographs. 6 photographs. Out of 6 photographs, we have to select 2 photographs. We have to place 2 photographs on the placed on notice board. In how many ways can this be done? अब 2 photographs को paste करना है notice board पर. How many ways? 2 photographs can be pasted out of a total of 6 photographs on the notice board. So here n is equal to 6, r is equal to 2. So total number of photos are 6, number of places are 2. The number of permutations are 6p2. 6 factorial divided by 6 minus 2, 4 factorial. तो डिनोमिनेटर में 4 फैक्टोरियल है, तो न्यूमरेटर में भी 4 फैक्टोरियल पर स्टॉप कर देंगे. 6 into 5 into 4 factorial. This 4 factorial will get cancelled. 6 5s are 30 ways. Now, see the 8th problem. Find the number of 2-letter word that can be formed using the letters of the word maths. One word is given, maths, M-A-T-H-S. Now we want to make a 2-letter word out of this 4. So how many ways we can make 2-letter word out of 5 letters? Maths. In maths we will have 5 alphabets. तो 5 alphabets में से 2 alphabet के combination निकालना है. We have to make a combination of 2 2-letter alphabets combination. So how many ways in which 2-letter word can be made out of a total of 5 alphabets? So here number of ways is equal to 5p2. The number of permutation are 5p2. So number of permutations are 5p2. 5 factorial divided by 5 minus 2 factorial, 3 factorial. So numerator में 5 into 4 into 3 factorial. 3 factorial gets cancelled. 5 4s are 20 ways. So 20 ways we can be able to arrange 2 alphabets out of maths. Fine. That's all. This is the end of 8th problem. So in this video I have explained you the meaning of the term permutation and combination, what is factorial, what is NPR, and what are the different types of permutations. We'll continue this in the next video.